So this is my code for the neural network. So at the start we import the system, and we're importing matplot library, pyplot, and keras, a bunch of different libraries from keras, such as like dropout and batch normalization. And then at the very start we're going to define the loading datasheet function and loading it from the CFAR10, and then we're going to prep the pixels and have the pixels be under the float 32 and have them trained under a certain size. And then we're going to define the model, and the model starts as a sequential. We're gonna set layers using the activation with the ReLU, kernel and initialization, padding, input shape, and we're normalizing the batch. And then we're going to convolve it in the 32 as a same thing, ReLU, with the padding, and then do another layer of batch normalization, and then we're going to add the max pooling 2x2 pool size, and then the dropout rate of 0.2, and we're going to then add the convolution in a larger or double the size essentially from the 32 to a 64, and normalize the batch. And then we're going to essentially do that throughout the code, doubling the size of it, and then we're going to normalize the batch, do the pulling again, but upping the dropout rate to 0.3, and then doing it again for 128 for the convolution filter, and then we're going to do the pulling size and then dropout rate, and then we're going to flatten the model and make it dense before we batch normalize again one more time and adding a 0.5 dropout rate, and we're going to fully connect the layers with 10 neutrons at the end, 12 at first and then 10, and then we're going to essentially save the model, return the model, and then we're going to have the diagnostic curves to plot or summarize the diagnostics and plot it and save the file, and then we're going to run the hardware test and then save the baseline. So you can see here I run the model and I couldn't get to the very start, but I ran two models, while one earlier and then one while I was at school. I got the validation accuracy of 90.5%, and we can also just run the model one more time if we wanted to, but the model does take 781 images and test it with 210 epochs, and you can see on the plot here, this is the cross entropy loss and the classification accuracies. The classification actually goes up and the cross entropy goes down. So yeah, that's the saved plot that we saved earlier. And then these take a really long time. These take a really long time for my computer. It's a couple hours. That's why I couldn't get it running or get the end of it for the video. I had it running while I was at during class. But yeah, it still works if we do run the code. So if I run it here, it'll load up and then it'll start training the first epoch. Yeah. Thank you, and have a good day.